Okay, hello guys and welcome to my channel. Now in this video, we want to talk about the partial fraction with linear factors. Okay, so we want to talk about a partial fraction in which the denominator has linear factors. So how can we deal with that? So I'm starting by saying if f of x over g of x is a proper fraction, that means that if the degree of the polynomial f of x is less than the degree of the polynomial g, okay, that would make a proper fraction. Okay, so if f of x over g of x is a proper fraction and the factors of g of x, that is the denominator, that is what we consider all the time. So if the factors of g of x are all linear, it has linear factors, that is to say the degree of the factors of each of the factors is 1. So you'll be having a linear function for each of the factors, linear, okay? For example, x plus b generally. Okay, so if the factors of g of x are all linear, now suppose u of x is a polynomial and v of x is another polynomial, are the factors of g of x, okay? Take note of this, where u of x is not equal to v of x. That is, they are not equal factors. Okay, so I'm saying that if u of x and v of x are the only factors of g of x. Now, since we know that the factors of g of x are said to be linear, that means that u of x is a linear polynomial and v of x is also a linear polynomial. All right? Okay, it means that we can write the fraction f of x over g of x, the proper fraction, as a. Now, a is just a constant, right? B is just a constant, okay, a constant polynomial. The degree is 0. So a, b, so a over the first factor, u of x, or any of them at all. Any of them, it doesn't matter which one is the first. And b over the other factor, okay? So a over the first factor plus b over the other factor. Our aim here is to solve for a and b, and when we get the values of a and b, we substitute into this and we equate the given fraction to its partial decomposition. So the whole process of solving for a and b is called the partial fraction decomposition. Okay, so what happens if g of x has more than 2 factors? Let's say 3, 4, 5. Then we'll just be writing this as f of x over g of x to be a over the one of the factors plus b over the other factor plus c over the other factor. So as many linear factors it will have, we'll just be writing it like that, right? So I'm going to show you how to solve this actually. So that is just a setup. Okay, so this is how we're going to solve this. So I'm giving us an example here. 1 over x squared minus 10x plus 9. This has linear factors, okay? And the factors of that polynomial in the bottom would be x squared minus 10x plus 9. So we have to factorize this, all right? So we have to look for 2 factors whose product will give us positive 9 and whose sum will give us negative 10. When you talk about negative 9 and negative 1, negative 9 times negative 1 will give us positive 9, and then negative 9 plus negative 1 will give us negative 10, right? Well, the actual thing is that when we take the product of these two guys, okay, the x squared and the constant in here, the product will give us 9x squared. So we see for 2 factors, when we multiply them to give us this 9x squared, when we add them to give us the middle 10, right? So the 2 factors will now be negative 9x and negative x and negative x, right? So if you multiply these two together, negative times negative will give us positive. 9x times x will give us 9x squared, which is the product of this and this, all right? 9x squared. Then negative 9 plus negative x, that is negative 9 minus x, that is just negative 10x. So I'm just reminding you how to do your factorization method, right? So since that is the case, we can rewrite that as x squared minus 9x. Okay, let me put minus x first. Well, it doesn't really matter. Minus 9x plus 9, all right? Okay, so we can go ahead and factor this. Okay, so we see for the first 2 terms here that x is common, so we can take x out of the bracket. We consider the first 2 terms only. So the remaining here will be x and this is just minus, we factored positive, so it doesn't affect. The remaining here, it will be 1 because we factored out the x. Okay, the next case, we are going to have minus in front, 9x and 9 is common, right? So we take out the 9, then we put a bracket. What is left here is just the x, and take note of this. This is positive 9, okay, and we just factored out a negative, so a negative is in front of the bracket. So if you multiply this bracket, okay, backwardly, we need to get positive 9, alright? So we just put down there a negative. So negative 9 times x is negative 9x, negative 9 times, sorry, not negative 9, negative 1. So negative 9 times negative 1 will give us positive 9, okay? So we get that back. Oh, this is not showing. Okay, so that is it. So I'm just doing this as a revision for you guys. So the next thing we like to do is, since this bracket and this bracket are the same, we just pull it out in front, right? Just factor out the common thing, the common terms, which is x minus 1, right? And x minus 1. So the remaining in the bracket will just be x minus 9, all right? So these are the two factors of the given denominator. Okay, so that is pretty simple. So I will just write those factors in place of the denominator. So I can go ahead and equate that to 1 over x, 1 over x minus 1, okay, times x minus 9. And now, from this statement, that if u of x and v of x are the factors, are the only factors of g of x, so we can write this down. So we can equate that to, well, I just add it with this. Now look at that, okay? So at the bottom here, I'm going to put down the first factor, x minus 1. And on the bottom here, I'm going to put down the second factor, x minus 9. Then on the top, we're going to write down a and b. We just put it alphabetically, right? So our end case to solve for the value of a and the value of b, when we substitute it back into this stuff here, we're going to get the partial fraction decomposition of the original fraction. Okay, we're going to get the partial decomposition of that. So that is just it, right? So these are the factors. We just write it this way. So factors are very important. Okay, so I would like to solve for this, and I would just like to use a very simple method, right? I'll call it the cover-up method. So when we have, it works for linear factors. That is just the unfortunate thing. Okay, so when we have linear factors like this, the first thing is to consider the first factor, the first fraction, okay, which is a over x minus 1. Consider that. Then you want to make the denominator here to be 0. Okay, so which number will you put for x such that the denominator here will be 0? Alright, so what is the value of x such that x minus 1 will be equal to 0? The value of x is just 1, right? You know, if you say x minus 1 should be 0, it means that x is equal to 1 by moving 1 to the right hand side. So this is what you will do when you've gotten that value 1. Come over to this fraction, okay, showing you the factors. Cover up the x minus 1, alright? Then substitute 1 into the other factor, x minus 9. So you substitute 1 for x into the other factor. That will be 1 minus 9, that is negative 8 at the bottom. Then 1 divided by negative 8 is just negative 1 over 8, like that, right? Okay, so that is the value of a, very, very fast. Yeah. Then for the value of b, to solve for the value of b, we have to make the denominator to be 0. So what is the value of x, which that will make the denominator here to be 0? The value of x is just 9, alright? You see, x should be 9, that means 9 minus 9 equals 0. So you are going to come here, cover this other factor up here, which is just this one, cover it up, substitute that 9 into this remaining factor and in the numerator as well. So there is no x in the numerator, so we just have 1 there. Then the denominator we are having x minus 1. So we put 9, that will be 9 minus 1. So that is x in the denominator, so that is 1 over 8. So the value of b is just 1 over 8. 1 over 8. So that means that this fraction, which is the same thing as this, alright, 1 over x squared minus 10x plus 9 is equal to 1 over 8 of x minus 1, okay, this is negative, plus 1 over 8 times x minus 9. That is 9. That is 9. Okay. So this is, you just substitute it backwardly. So in place of a, you put negative 1 over 8. Right? Let me take it step by step. Now this will be equal to, in place of a, I will put negative 1 over 8. Then I divide it by x minus 1. Right? I add it with, in place of b, I put positive 1 over 8. I divide it by x minus 9. Okay, so my fractions are not balanced. Let me make it balanced. 1 over 8 x minus 9. So you have a fraction at the top. In fact, this denominator of the numerator will come down to the numerator of the denominator. So this is going to be negative 1 over 8 times x minus 1 plus positive 1 over 8 times x minus 9. Okay, so that's the end of our example number 1. But this is very, very important to note. So I am just going to go ahead and solve another example under these linear factors for you guys, and possibly another example, but just noting this is enough for you. Okay, thanks for watching, and please subscribe to my channel. Turn on that notification so that you'll be notified. Okay.